Hello guys, welcome to my channel. In this video we're going to talk about Trident. Trident is a powerful force testing framework designed specifically for Anchor based program on Solana blockchain. Trident is developed by ackeeblockchain. So what is Trident? Trident streamlines the force testing process, making it easier for developers to identify and fix vulnerability in their smart contracts. It automates many tedious tasks, allowing you to focus on what really matters: building secure application. Think of it as the first line of defense, or the thing that every developer has to do. It's a very important tool. So let's discuss fuzzing. Fuzzing is a software testing technique that involves providing invalid, unexpected, and random data as input to a program. This helps uncover bugs and vulnerabilities that traditionally testing methods might miss. It's like throwing a curveball at your code to see how it reacts. So, we're talking about Trident and fuzzing. Trident is a tool that allows you to do fuzzing on Solana program, and fuzzing is like throwing random inputs to your program to see which one break it. So think of it as the first audit you have, a self audit. It's important that every project write a first test before going live. So now let's discuss how to install Trident. The first thing we'll need, and here the list say we need to install Rust. But if you're using a Windows machine, the first thing you should do is to install a WSL. You can install a WSL by going to your PowerShell and typing WSL install. After which you can follow through the whole documentation and follow the guide on how to install a Linux distro on your PC. Most probably Ubuntu. So after you're done, you install Rust. You can install Rust by copying this command and pasting it in your terminal. So after pasting it in your terminal and installing it, for you to know whether it's installed or not, you have to run this code: rust c version. So this will bring out the version of Rust you have on your PC. So you can see I have Rust C 1.79.0. That means it's installed on my PC. So the second thing you will need is to install Solana on your PC. I'll put link in description to all of this so you can navigate it easily. So to install Solana toolchain, you have to copy this code to your terminal and run it. So after you're done, to confirm whether it's installed successfully or not, you have to run Solana version. As you can see, I have Solana CLI 1.17.25. So the third thing is what we need Anchor. So here you need to first copy the code here to your terminal and run it. If it fails, because it might sometimes, if you're using if you're on Ubuntu or something, you have to run the second command and run it again. So after that, you can run avm install the latest version, the version you're working on. If you're working on the latest version, currently is 0.30.1, so that's the latest. If you're running 30.0, you can select it here, and the second command should be avm use latest. Then you will have to verify the installation by typing anchor dash dash version like this. So as you can see, I have Anchor CLI 0.30.0. So I'm done with the installation. One more thing, you will need to install Fuzz. You need to install Fuzz. You have to type cargo install Fuzz to your PC. So you will need this. It's a Google-based Fuzz Trident is based on this hung forces like open source force Fuzzer. You can read more about it by looking at the documentation here. I think this is the Rust implementation. So you can run it by cargo install hung force. I already have it, so I don't need to reinstall. So that's basically what you need. So now let's dive into the product. So Fuzz and software testing, we've explained this. So you can read through this documentation to get the overview of what is fuzzing. So now let's see what features does Trident offers. The first feature it offers is the automated parsing. Trident automatically passes Anchor-based program, generating necessary implementation for deserializing instruction accounts. This saves you time and effort. That's one of the interesting features they have. The second one is the customizable templates, which allow you to tailor your first test to your specific needs with customization templates. You will see it in a second. And the command line interface, a user-friendly CLI, simplifies executing and debugging first test, making it accessible for every beginner. That's another features they have. Then the execution order customization, which involve testing different sequence of instructions to uncover potential vulnerabilities related to execution order. And last but not the least, the comprehensive testing, like to conduct a thorough and effective test first testing by combining all of the above: the execution order, the instruction parameters, and instruction account. So it's a very good one. So let's see the first test. Okay, I haven't explained how you install Trident itself. So after installing all of this Rust, Solana, Anchor, and Fuzz, you need to install Trident also. I have Trident installed. After, you need to copy this command, cargo install Trident CLI. I already have it. I just need to like Trident to verify my installation. Trident dash dash version. You see I have 0.6.0, which is the latest version. You can see it here. So let's go to the first test. So if you type this command after you have an installation of Trident, this Trident init for Fuzz, you will have a scaffold like this, a project root. This is your root project, and you have another folder called the Trident tests. Under it you will have the first test and the Fuzz 0. And this comes by default. So this is how the scaffold will come. You can add some other Fuzz that you want to write. We'll get to that. So add a first test. Let's say you want to write a first test for something specific. You can write Trident Fuzz add. This command will generate this scaffold for you. But if you want the whole suite, a whole suite of the whole thing, you can just type Trident in it. It will create all the tests for you, and even the POC tests. So let's go to the Fuzz life cycle. So let's explain a bit about fuzzing before I still run. Let's go to the diagram and explain it. So here we have a diagram. You can see we have fuzzer iteration, which is equal to 0. This is the initialization stage, where the fuzzer iteration is set to 0. It means the count at that time is 0. Then we have the iteration check. This is a decision to check if the number of the further iteration is less than the maximum iterations. If the condition is met, then the process continues, otherwise it ends. So if the condition continues, down is to end. If it continues, that's the this generate instruction. The further generate a set of instruction to be tested. Those labeled as the pre-IX, the IX, and the post-IX, IXS. The pre-ISX represents the pre-instruction. This represents the actual instruction, the ISX, the IXS, forgive my pronunciation. And we have the post-IXS, which represent the post-instruction state. And we have the instruction loop, like for X and instruction. It's basically for each instruction in the set, the fuzzer will generate an instruction account, retrieve the necessary accounts or data required to execute the instruction, and also get the instruction data. Then we have the execution process. This create the execution process. It creates a pre-instruction account snapshot, which capture the state of account before executing, and then execute the instruction. That's when the actual execution of the instruction take place. Then we have the create post instruction snapshot, which capture the state of account after executing the instructions. And the invariant checking. This check for invariants. After executing all the instructions, the further checks invariants to ensure that the program state adhere to expected properties or condition. For instance, checking if the system remains stable and correct. So that's what it does. And here the iteration continue adding. Like the further increment the further iteration counter by 1 and loop back to check if more iteration are needed or the process should be ended. So that's basically what this diagram is saying. There is a video on the IQ blockchain channel that explain everything in detail. Like it's a very comprehensive video, so I'm just making a review. For more information you will need to check that. So how to write a Fuzz test. Let me open this up. Like the first step, let's check the first step. So to write a Fuzz test, the first thing you need to write is once you have finished the implementation of Fuzz test, you can run the Fuzz tests as follows. Oh, this is if you have a target Fuzz test. This is the Trident toml file. This is where you set number of iterations, number of time you want it to iterate. At this timeout is the timeout seconds, it's already written. And we have the thread, it's like number of concurrent threading. We have the keep out false. The all other settings remain the same. So don't tamper with this, you just need to like adjust your iterations. I think that's all you need to do here. So let's check what other features do they have. Specify account. This is about setting the account. Like we have a struct here, the Fuzz account. So the account of the Fuzz, you need to provide this information: the key pair, the PDA store, the token store, and the min store. So this is not the video for this, but like you can read through this documentations and find out more. So now let's just go to some examples, Fuzz examples. I'll put link in description for more comprehensive video. So we have this hello world. Let's see. So we are on the GitHub page. This is the Hello World program. The Hello World program. Okay. They give some descriptions right here. Hello World example for Trident Fuzz. A simple Solana program initializes to Hello World account, which holds one U8 field called input. The store Hello World has a program derived address. So this is I think the program. We have the invariant checks here. They have the specify instruction account, the instruction data, and the pseudo random account to reuse in further, and lastly the program itself. So now we'll clone this program. How do we do that? We just head back to the Trident to copy the whole thing. Yeah, we copy this, we go to our terminal, we press git clone, we paste. Now we are cloning Trident. We are cloning it so we can locate this. So let's wait a moment. I'm having some issues with my PC, but bear with me. My network also is kind of slow. So we're done installing it. We just need to type cd Trident and cd examples. I think it's in the example folder, and cd fuzz. I think it's an underscore tests. Oh, it's not. ls. So we have a bunch of program here. Here is the hello world. cd hello world. So that's what we need to do. So we are there right now. Let's go back to the documentation. We can just type Trident test. It's complaining about some version here. The Ancolang version 0.29 and the current CLI version is 0.30. Doesn't match. This can lead to unwanted behavior. To use the same CLI, add torture. Anchor version. Okay. So it's taking more time than expected, and we can wait for it forever, so it to make the video very long. So that's basically how to do it. I'll post a link to a more comprehensive video if you want to learn how to write a Fuzz test using Trident. This is just a walkthrough. So I'm going to end it. And open it on VS Code so that we can see the code. Okay. In the meantime, I also have an article I wrote on Trident, so you might as well visit the article. It has a lot of information on it, on how to use Trident. Here is the article: a comprehensive guide to Fuzz testing, a comprehensive guide to Fuzz testing and code-based program on Solana. So you can go through the background, the installation. If you don't understand any point in this installation, this is a go through um this is important. You can just go through it to get you started. My PC is acting up. I need to end the video now. So I'll put link in description to this, to the video on YouTube. I think ackeeblockchain have a very good video on YouTube that explains it better. So I think the VS Code is now up. Sorry for the inconvenience. My PC is a bit faulty. So in the meantime,